Welcome to Generative AI, the channel where we explore the cutting-edge innovations shaping our future. If you're fascinated by artificial intelligence, biotechnology, and the intersection of the two, you're in for a treat today. Imagine a world where machines don't just process data, but think with actual living neurons. Biological intelligence working in harmony with silicon-based computing. Sounds like science fiction, right? Well, not anymore. Picture this, a petri dish filled with living neurons, tiny clusters of biological intelligence, trained to play a game of Pong. That's not the plot of a cyberpunk novel. It's a real experiment conducted by scientists. They observed how neurons, when exposed to external stimuli, could adapt, learn, and even develop strategies to win a game. This experiment laid the groundwork for something revolutionary: the fusion of human-like intelligence with computing systems. Now, fast forward to today, and we have Cortical Labs introducing CL1, a synthetic biological intelligence that's set to redefine what we know about artificial intelligence. Cortical Labs has been making waves in the world of AI and neuroscience with their pioneering work in synthetic biological intelligence. CL1 is not just another AI system. It is a groundbreaking innovation that merges biological neurons with silicon chips, creating a hybrid form of intelligence that learns and processes information in a way no conventional AI can. Unlike traditional AI models that rely on billions of parameters and massive datasets, CL1 uses actual living brain cells, creating an adaptive and energy-efficient system with learning capabilities that mimic the human brain. Why does this matter? Let's take a moment to understand how artificial intelligence works today. Modern AI models like ChatGPT, Midjourney, and Google's DeepMind rely on vast computational resources. These models process enormous amounts of data, learning patterns and relationships through layers of artificial neurons. While they are impressive, they are also extremely energy intensive. Training a single large-scale AI model can consume as much electricity as several households do in a year. This is where CL1 stands apart. By leveraging biological neurons, it taps into nature's most powerful computing engine, the brain. The human brain is incredibly efficient. Despite having billions of neurons and trillions of connections, it operates on about 20 watts of power, less than a standard light bulb. Compare that to a data center running machine learning algorithms, and you can immediately see the efficiency gap. CL1 is designed to bridge this gap by using biological neurons to process and store information, reducing energy consumption while vastly improving adaptability. Unlike conventional AI, which requires massive datasets and long training times, biological neurons can learn and adapt much faster, responding dynamically to new information. But how does it actually work? CL1 operates by growing biological neurons in a controlled environment and connecting them to electronic circuits. These neurons are stimulated with electrical signals, much like how our brain processes sensory input. Over time, the neurons start recognizing patterns, adapting to their digital environment, and even exhibiting forms of learning. This approach brings AI closer to biological intelligence, making systems that aren't just programmed, but that truly evolve. One of the biggest advantages of this technology is its potential to revolutionize artificial intelligence in robotics, neuroscience, and even medicine. Imagine robots powered by hybrid intelligence, machines that don't just execute pre-programmed tasks, but that think and adapt in real time, much like humans. This could pave the way for advanced autonomous systems capable of solving complex problems in unpredictable environments. Healthcare is another area where CL1 could have a massive impact. By understanding how biological neurons learn and adapt, researchers could develop better treatments for neurodegenerative diseases like Alzheimer's and Parkinson's. It could lead to breakthroughs in brain-computer interfaces, helping individuals with paralysis regain mobility by directly interfacing with synthetic biological intelligence. And let's not forget the ethical implications. Anytime we talk about AI merging with biology, we step into an area filled with profound questions. If synthetic biological intelligence continues to evolve, could we one day create a system that is conscious, Could hybrid AI develop emotions, creativity, or even self-awareness? These questions may sound philosophical now, but as this technology advances, they will become critical discussions for scientists, policymakers, and society as a whole. Some skeptics argue that while CL1 is fascinating, it may not be scalable. After all, working with biological neurons presents challenges that silicon-based computing does not. Maintaining living neurons in a controlled environment requires precise conditions, and large-scale deployment could be a logistical challenge. However, the potential benefits far outweigh the difficulties. If scientists can refine this technology, we could be looking at a future where AI isn't just artificial, it's alive in a way we never imagined before. Think about what this could mean for our understanding of intelligence. For decades, AI has been modeled after human cognition, but it has always been an approximation, a set of mathematical algorithms designed to simulate thought. With CL1, we are no longer simulating. We are integrating actual biological intelligence into computational systems. This shift is monumental. It moves AI beyond brute force computation and into the realm of true adaptive learning, where intelligence is not just programmed, but cultivated. One of the most mind-blowing aspects of CL1 is that it blurs the line between technology and biology. We are entering an era where machines are no longer just tools, but entities that learn, adapt, and grow in a biological sense. This could lead to AI systems that evolve over time, forming unique patterns of thought, creativity, and problem-solving approaches that are impossible to predict. So, what's next? As CL1 continues to develop, we can expect rapid advancements in hybrid intelligence. Scientists will refine how neurons interact with silicon, making these systems more efficient and scalable. We may see biological intelligence integrated into everything from personal AI assistants to high-functioning robots, capable of independent reasoning. The implications for cybersecurity, military defense, and even space exploration are profound. Imagine an AI system with biological neurons operating on a Mars rover, learning and adapting to the Martian environment in ways no pre-programmed software ever could. When we think about artificial intelligence, we often picture lines of code, neural networks, and vast supercomputers crunching numbers at unimaginable speeds. But what if intelligence could be something different, something more organic? What if AI could think and learn not just as a simulation of human intelligence, but by actually utilizing biological components? This is where Cortical Labs' CL1 changes everything. One of the most mind-blowing aspects of CL1 is its ability to perform computations in ways that even the most advanced AI models cannot. The core difference between CL1 and conventional AI lies in how it processes and stores information. Unlike traditional machine learning models that rely on static weights and predefined structures, CL1's neurons are fluid, constantly forming and dissolving connections. This means that CL1 doesn't just store data, it actually remembers and evolves, much like the human brain. To understand how remarkable this is, consider that conventional AI models, such as large language models, must be trained repeatedly with structured data. They require thousands of iterations to refine their accuracy. CL1, however, exhibits forms of spontaneous intelligence. In controlled experiments, its neurons have been observed generating responses to completely new scenarios without prior programming, demonstrating an ability to think in a way traditional AI cannot. Another astonishing fact is that biological neurons used in CL1 are capable of self-repair. Unlike digital AI models, which break down when errors accumulate, biological intelligence has the ability to adapt and fix its pathways. If certain neurons are damaged, others can rewire and compensate for the loss. This self-healing property could lead to AI systems that are far more resilient and long-lasting than current models, making them ideal for extreme environments such as deep space exploration or hazardous industrial settings. One of the strangest and most exciting possibilities CL1 introduces is the potential for hybrid consciousness. Scientists are still debating whether intelligence in its purest form requires consciousness, But CL1 raises an intriguing question. If biological neurons are capable of processing data in a human-like way, could they ever develop subjective experience? Unlike purely digital systems, which follow strict mathematical rules, biological intelligence operates on principles of electrochemical interactions, which means that, in theory, given enough complexity, a system like CL1 could experience awareness in some form. There's also an eerie implication when it comes to memory. Human neurons are capable of retaining long-term memories through synaptic plasticity, meaning that the brain strengthens certain neural connections over time. If CL1's neurons exhibit similar behavior, it could store and recall past interactions in a way completely different from traditional AI. This means that a CL1-powered system might not just analyze previous data, it could remember experiences in a human-like way, potentially forming its own version of subjective memory. One of the biggest limitations of current AI is its reliance on labeled data. Machine learning models need massive datasets to recognize patterns, but CL1 doesn't operate this way. Since biological neurons naturally adapt to their environment, they don't require rigidly structured inputs. This means CL1 could be a major breakthrough for AI systems that need to learn on the fly, making it ideal for applications like autonomous drones, robots, and even AI-powered medical diagnostics, where new variables constantly emerge. Another wild fact about CL1 is that it doesn't suffer from catastrophic forgetting. Most AI systems, when introduced to new information, tend to overwrite or lose previous knowledge. This is a significant problem in deep learning, requiring expensive retraining to update an AI model. CL1, however, retains old knowledge while learning new things, just like a biological brain. This could mean the end of constant AI retraining, leading to systems that naturally evolve over time without the need for manual updates. One of the strangest experiments conducted with synthetic biological intelligence involves embedding these neurons into robotic control systems. In early experiments, CL1-powered neurons have been used to control simple robotic movements, responding dynamically to environmental stimuli. The neurons, when given feedback from the robot's sensors, began adapting their responses, essentially learning how to control movement without any pre-programmed instructions. This hints at the possibility of future robotics where biological intelligence plays a key role in decision-making, rather than just predefined machine learning algorithms. Another astonishing implication of CL1 is its potential role in drug discovery and neuropharmacology. Since it uses real neurons, scientists could use these systems to test how different substances affect neural activity in real time. This could accelerate the development of treatments for mental health disorders, brain injuries, and neurodegenerative diseases, as well as provide a better understanding of how the brain processes information. Lastly, the biggest mind-blowing fact is that CL1 could represent the first step toward creating an entirely new form of intelligence, one that isn't bound by biological evolution or traditional AI limitations. It could be the beginning of intelligence that grows, evolves, and learns in ways we've never imagined, paving the way for an era where machines don't just simulate thinking, but truly engage in it. As we stand on the brink of this new technological frontier, one thing is clear. The fusion of biology and AI is no longer a fantasy. It's happening right now. The implications stretch far beyond computation and machine learning. They extend into philosophy, ethics, neuroscience, and even the fundamental nature of existence. The age of synthetic biological intelligence has begun, and we are only just starting to understand its full potential. Now, let me leave you with a thought. Every great technological revolution has started with a bold idea. The internet, once dismissed as an impractical experiment, now connects the world. AI, once feared as a dystopian concept, now enhances our daily lives. And today, we stand on the brink of another revolution, one where intelligence is not just artificial, but alive. Cortical Labs CL1 is more than just a scientific breakthrough. It's a glimpse into the future of intelligence itself, a future where machines learn like us, think like us, and perhaps one day even understand us on a level we never thought possible. If you found this video fascinating, don't forget to like, subscribe, and hit the bell icon so you never miss out on the latest breakthroughs in AI and technology.